The interstellar medium. As the name implies, we're talking about material between the stars. So interstellar, between the stars. And the vast majority of what's found between the stars is gas, about 99% gas. Most of that is hydrogen, a little bit of helium. The remaining 1% is what we call interstellar dust, and that could be really just anything other than hydrogen or helium. So pretty much every other element in the periodic table can show up in this interstellar dust. Now that's what's found between the stars, fairly evenly distributed. But there's also gas and dust that is more concentrated into different types of clouds. So the cloud types, the first type is called an H II region. That's a Roman numeral 2. And H II means that the hydrogen has lost its electron. So recall that a hydrogen atom, you've got a proton in the nucleus and an electron orbiting around it. So ionized hydrogen, H II, is really just means you've got free protons and free electrons doing their own thing, but they're not bound together. It's been ionized. And here we see a picture. This is the Trifid Nebula, which is a lovely example of an H II region. But why does it get ionized? Well, it turns out that you've got star formation. So these are forming stars here. And forming stars are hot. And so remember when we talked about absorption spectra, that the electron can absorb light and it'll move out to a higher orbit. So it's still in orbit, but it's at a higher energy level. Well, if it absorbs a lot of light, a lot of energy, that electron will just break free. So that's what's happening here. The stars are producing so much energy that it's causing the electrons to break free. But of course, that's a high energy state. Nature is lazy, doesn't want to stay in that high energy state. So eventually, the proton and the electron are going to get back together, and the electron's going to go back into orbit. That's a lower energy state, so it emits light. And so this glow, all this red glow, is basically hydrogen emitting light as the electrons and protons recombine. Another type of cloud is neutral hydrogen. And by neutral, we mean electrically neutral. So it's got an even number of positive and negative charges. So in this case, one proton and one electron. So the charges balance out and the hydrogen atom is neutral. Well, it turns out that when you have cold, neutral hydrogen, you wouldn't expect much to be going on as far as producing light. But it does do one thing. It experiences what's called electron spin flip. So here we see our proton and our electron. And in this first picture, they are both spinning in the same direction. Turns out that's a slightly higher energy. And so it wants to go into a lower energy. Well, the lower energy is if our proton stays spinning in one direction and our electron flips over so that it's spinning in the opposite direction. That's the lower energy state. Now, how do they get into the higher energy state in the first place? Usually collisions with other hydrogen atoms does that. So hydrogen atoms zipping around, they bump into each other, and suddenly you've got a higher energy, but it doesn't want to stay there, so the electron flips over. Well, when it loses energy, of course, it's got to emit something. And in this case, what it emits is light with a wavelength of 21 centimeters. So that's a fairly long wavelength, so you know that's low energy. So it is a very small energy difference between the two states, but enough to actually produce light when it flips over. So here you're seeing the electron in the up position and the down position, and so when it flips over, it's producing this light with 21 centimeter wavelength radiation. That radiation is so long, it produces radio waves. So that's in the radio part of the spectrum. So to see this, we use a radio telescope. So radio telescopes let us map hydrogen, because hydrogen is everywhere. It's the most abundant element in the universe. And so the fact that hydrogen does give off this radio wave means that radio telescopes become very, very useful for producing maps of where hydrogen is located. A third type of cloud is called a dark nebula. And here we see the Horsehead Nebula. And so in this case, what we're looking at is darker, denser dust in front of a light source. In this case, it's actually in front of a H2 region. This pink back here is an H2 region. It could also be in front of stars. So you're basically seeing a silhouette. Let's see if I can spell it correctly. That's close. So the silhouette is the cloud, and it is blocking the light, so we see it as a dark silhouette in front of a light source, and so hence the name a dark nebula. Another kind of cloud is called a reflection nebula, and so as the name implies, it's reflecting light, and in this case light from a nearby star. So this blue cloud that you see is being illuminated by this star. So this star is surrounded by this little gas cloud, and the light from the star is lighting up that cloud. This is often associated with newly formed stars, because stars form out of clouds of gas, but they don't use all of that cloud. And so for a brief period of time, you have a new star plus some of the material that it formed out of. Over time, that cloudy material will get blown away by the solar winds coming off of this star. But for this brief period of time, that cloud is around the star, and the star is lighting it up, and you get this reflection nebula. And our last kind of cloud is a molecular cloud. in this case molecular hydrogen. So that is H2. So essentially two hydrogen atoms bound together. And here we see the Eagle Nebula. That's a nice H2. Well, H2 is the ionized molecular hydrogen. And these are associated with star formation. So where you have molecular hydrogen, it's usually a little denser, so that leads to star formation. And that is in fact what's happening here in the Eagle Nebula. These kind of darker regions are where it's densest, and that's where stars are starting to form. And then this outer part is ionized hydrogen. So you've got a mixture of cloud types because you've got kind of a dark nebula going on here because it is blocking some of the material. You've got molecular hydrogen and you've got ionized hydrogen as well. So lots of things can happen together in one place, but they all fall into these different categories of clouds that are composed of material found in the interstellar medium.